So hello future achievers. So we are now going to start our third session on unit and measurement. In this third session we are going to learn about the dimension analysis. Basically in the last session we have covered what is dimension analysis, and we have seen how to find the dimension of some physical quantities, and then we have seen the principle of homogeneity also, and we have solved some previous year questions, one previous year question and some other questions. And then we have see one property, that how we can check the correctness of the formula by using the by using dimension analysis. That is another you can say another application of dimension analysis. Now in the today class we are going to discuss about the how we can do the unit conversion by using a dimension analysis, and how we can find the formulas by using the dimension analysis. Clear? So let us start. So the first thing we are going to cover today is conversion of 1 unit into another. Okay, today we have to see this thing. Clear? So let us start. So you have to simply remember one formula, as no one is going to ask this topic, but as we are covering everything, so the formula you have to remember for this is N1 U1 is equal to N2 U2, where N1 is where N is basically represent numerical value. Okay, numerical, if you remember the first class, it is a numerical value. And the N2 and mu is, or U is unit, simply. So how, just we see one example, then we can understand. Let's take one example. The example is 1 Newton is equal to how many dyne? Dyne, you know, dyne is what? It is gram per centimeter plus by square, and this is what as a kg per meter square. That is the difference. It is a SI system, this is CGS system. This is MKS system, this is CGS system. So you have to do this conversion. What you have to do? You have to apply this formula. Simple. What is the dimension of this? The dimension will be M L T minus 2. Clear? What is the dimension of this from here? Or you can write it M1 L1 T1. This is M2 L2 T2 minus 2. Okay? Then you have to write the values. What is the value? 1 N1 into unit 1. What is a unit 1? This is my unit 1. That is kg per meter per centimeter square. That is my this unit is equal to this N2. I don't know, I have to find. What is a unit 2? This is gram per centimeter plus square. See, from here I can cut my second square. What I will get now? I will get 1 kg per meter, 1 kg meter, sorry. That is equal to gram into centimeter into N2. So from here I can write my N2 is equal to how much? My N2 will be how much? If you can divide this thing, you will get kg meter per gram centimeter. Now you tell me, either you convert this into this or this into this, it depend upon you. Okay, 1 kg is equal to how many gram? It is equal to 1000 gram. Correct. And 1 meter is equal to how many centimeter? It is equal to 100 centimeters. This is gram and this is centimeter. So centimeter will cancel out, gram will be cancel out. How much you will get? My N2 will be equal to 10 to the power 5. So from here what we get? We get 1 Newton is equal to 10 to the power 5 dyne. Okay, clear? So my 1 Newton is 10 to the power 5 dyne. Any doubt? If you have any doubt, you can tell me. Clear? So this is how we convert a 1 unit to another unit. Let's take one more example. Then it will be more better. You know, G value is 6.67 into 10 to the power minus 11 Newton meter square by kg square. Okay, this is the thing. You have to convert this into Newton per Newton centimeter square plus by gram square. This is the conversion you have to do, and you have to tell me what is the value. You have to convert. Just solve this. Just for your practice, I am giving this type of question. Otherwise, this type of question are not important. Okay, just solve this and tell me what is the answer. Just write down your answer. I give you 1 minute to solve it. Oh, sorry, one mistake is there. This should be dying now. Yeah, now solve it. It's very easy. Just you have to simply apply the formula N1 U1 is equal to N2 U2 and you can easily solve it. It's very easy. I hope everyone has solved. So what you have to do? Simply have to apply the formula. So solution. What you have to do? You have to apply the formula, that is 6.6. 6.67 into 10 to the power minus 11 into Newton meter square divided by kg square is equal to some N2 into dyne into centimeter square by gram square. Now just you can easily solve it. Now you have to simply do the conversion here now. Okay, it's simple conversion you have to do to solve this. Okay, just do this. 6.67 into 10 to the power minus 11 See, Newton I convert into the dyne, so it is 10 to the power 5 dyne as we have seen. And 1 meter is equal to how many centimeter? 100. So it is 100 square centimeter divided by 1 gram is 1 kg is equal to how many grams? That is 1000 gram square into gram square. So from here, what will we get? Newton into dyne into centimeter square divided by gram square. So this everything will be cancelled out, and what is the left? N2 will be equal to what is? See, this is 10 to cube, 10 to the power 6, 10 to the power 6 cancelled out by 10 to the power 5, you will get 10 to the power minus 1, that is 10 to the power 4, 4 1 3, so you will get 6.67 into 10 to the power minus 8. That is my unit. That is my value in CGS unit. Clear? Any doubt is there? Okay. Shall I proceed further? Okay. So you can take one more example if you one homework as if you want. Okay. Take one homework. Let's, for example, suppose the neta value is 2.5 in kg minus 1, you have to find this value in gram second minus 1. Okay, I don't know whether this type of question exists or not. I framed it. Okay, you have to solve it for your practice. I am giving you to convert this into gram centimeter minus 1 into second minus 1. Clear? Okay, so let's move forward. Yeah, now we are going to the most important session, that is very important. It's regarding the JEE point of view, NEET point of view, advanced point of view, whatever point of view you can say, it is very important. That is how to find the formulas by using the dimension analysis. Okay, so the next is formula by using dimensional analysis. Okay. Now see, this is for like, as we have seen that we can check the correctness of the equation by using the dimension analysis. So there is also one thing is that we can also derive the equation by using the dimension analysis, and this is the very, like, there is no theory in this. You have to follow the certain steps. What are the steps I am going to tell you, and just you have, by following that steps you can solve the any problem. For example, let's take a first start with a very simple problem. Okay. Okay, suppose let the F, that is force, depend on the M and acceleration A, derive the equation. Sorry. Derived let force is there, which is going to depend upon the mass, and you have to find the and depend upon the acceleration, you have to derive the equation. See, you know that the equation is force equal to mass acceleration, but suppose I don't know, I want to check by using the, I want to derive by using the dimension analysis. Okay, so let us, how we will going to do. Your first step is step 1. Okay, only. Okay, step 1. First write like this. Okay, let force depend upon, let force directly proportional to m to the power some alpha, I don't know, and a to the power some beta. Okay, because I don't know whatever the value it can be, it can depend upon force m square also, a cube also, anything. Let for now just write it some m to the power alpha and a to the power beta. Okay, now step 2. Step you will say into and a to the power beta, where k is some constant. Okay, where k is going to be some constant. So this is now after that every quantity and apply the condition of the correctness of equation. That is thing you have to follow. Just apply this here. So force will be ml t minus 2 is equal to, what is mass, m, sorry, k is also here, m to the power 1, l to the power 0, t to the power 0 to the power alpha. Then what is the dimension of acceleration? That is m to the power 0, l to the power 1, t to the power minus 2 beta. Now what will it become? This will become k into m to the power alpha, l to the power 0, t to the power 0, then m to the power 0, l to the power alpha, t to the power minus 2 alpha. Okay, and this is equal to ml t to the power minus 2. Now just from here ml t minus 2 is what you see k is constant, k have no dimension obviously. Add the powers, m to the power alpha, alpha plus 0 means alpha, l to the power 0 plus alpha means alpha, and t to the power 0 plus minus. all powers are alpha only. Oh, sorry, it is beta na. This is beta and this is 2 beta. Clear? So sorry, so here also same thing, this is beta. If I did mistake, just tell me, sir, you are online, how I can tell you? Okay, no issue. 2 beta. Okay, now what is the condition of correctness of equation? What is the correctness of condition for correctness of equation? The dimension on the left hand side and the dimension of right hand side should be equal. See, that is only the condition now. The dimension on left hand side should be equal to the dimension of right hand side. That is a condition, because if it is not same, then it is not a correct equation. So just you apply the equal that condition. So the dimension of m is alpha here, that is equal to here dimension 1. The dimension of beta should be equal to 1, and the dimension of t should be equal to minus 2, beta should be equal to minus 2, that means again beta is equal to 1. So from here we get alpha value as 1 and my beta value as, my beta value as 1. So my equation will become f is equal to k, put the value in this equation, m to the power in SI system. This k value is, we know it is 1. So my final equation is, what is the final equation we will get? Finally we will get my f is equal to m into a. Clear? Finally we will get my f is equal to m into a. Okay, so it's very simple step. You have to, whatever type of question is will become, you have to do the same steps. Okay, you have to follow the same steps. These steps you have to remember everywhere, and remember, see, this constant value you don't know. Remember, in the paper, if they give the answer, then the constant this constant will be there. Otherwise, you just take it as 1 or something. It will be something will be given there. Otherwise, you have to follow the same step. Okay, just don't take a stress about this constant. That is not necessary. Okay, just you have to follow the steps. So the formula will be m into a. Clear? Any doubt? Let's do some examples, then you will understand more better. Okay. Okay, let's do one example. Okay, let's take one example. Let the energy of particle, that is E, depend on the amplitude amplitude, mass, omega, that is, what is omega? mass, angular velocity omega. So it is then find the expression of E. You have to find the expression of E. Solve it. Just find the expression of E. So I hope everyone has done this. What you have to do, it's very simple. Solution. What is the first step? First is my energy. That going to be depend upon directly proportional to first is amplitude, that is A, okay, power alpha. Then mass, m to the power beta, and the last is velocity. Sorry, angular velocity, not velocity. That is omega to the power gamma. Okay, then what you have to write, my E is equal to some k a to the power alpha, m to the power beta, and omega to the power gamma. Where what is the dimension of a E? That now you have to remember it because we have repeated a lot of times. Now what is amplitude? Amplitude is length only, distance only, L to the power alpha. What is m? Mass, that is m to the power beta. Okay. And what is omega? Omega is 2 pi f, where 2 pi has no dimension, f is frequency, frequency dimension is t minus 1, that is gamma. Okay, so from here just you will get, now you no need to write each and every step, okay, because you are preparing for competitive exam. So from here if you equate, you will get beta is equal to 1, my alpha is equal to 1, and my gamma is 2. So what is the expression I will get? My expression will be E is equal to some k times of some a to the power 1, m to the power 1, and omega square. Clear? Omega square. Any doubt? Okay, so this is the expression, derived expression. Okay, any doubt is there? Shall we proceed further? Okay, let's take one more example, and that is slightly different. It is a previous year of JEE PYQ. Okay, the question is, let me see the question once because it has a some. Okay, yeah, so it say let the F, that is force, velocity, that is V, and time is the fundamental quantities. Are the fundamental quantities find the find the find the find the expression of energy. You have to determine the expression for energy. Clear? You have to determine the expression for energy. Let me give you options also. Okay, so the first option is FV. Options are not visible. Options are not visible to me, so let's solve. We will check, we will match it. Okay, so this is the question. So how will you solve? See, now the fundamental quantities, they said now the force, velocity and time is a new fundamental quantities. Initially what we have seen, we have only 7 fundamental quantities. Now by them, they themselves only, they have derived as new fundamental quantities, and by this new fundamental quantities you have to find the answer. Then what approach you have to follow? You have to follow the same thing what I told you, no other steps. You have to write my energy, sorry, you have to write my energy is directly proportional to, what is the value it given? Force to the power alpha, then velocity to the power beta, and then time to the power gamma. Then from here you will get my energy is equal to some k. What is force? It is LT minus 2 to the power alpha. What is my velocity? That is LT minus 1 to the power beta. And what is my time? T to the power gamma. Just you put the value ml square t minus 2. Now energy you should remember. Now you know how to find those, so you can find and check. This will become m to the power alpha, L to the power, see alpha here, beta here, so alpha plus beta. Clear? And t to the power minus 2 alpha minus beta plus gamma, minus 2 alpha minus beta plus gamma. So from here if you equate, you get alpha is equal to 1, beta, sorry, alpha plus beta is equal to 2, and minus 2 alpha minus beta and plus gamma is equal to minus 2. So if you put here, you will get a beta is equal to 1, alpha value if you put here you will get beta, and from here you will get minus 2 minus 1 plus gamma equal to minus 2. So you will get gamma is equal to 1. So alpha is 1, beta is 1, gamma is 1. So my equation will be, I think I did everything correct or is wrong. Oh sorry, LT minus T ml square T minus 2 yeah, alpha plus beta minus 2 alpha. Okay, correct. So this will become, my energy will become some k times of what? FVT. K times of some FVT. Oh sorry, alright. So this is your answer. Okay, any doubt is there? Any doubt is there till now? You can tell if you have a doubt. No doubt? Okay. Shall we proceed further? Yes, we can. Okay. So let us see. So what we have done till now in the dimension analysis, we have seen first we have seen like what is dimension, then we have seen what are the different types of dimensions, we have find, then we have seen this important property, then we have seen principle of unity, then we have seen this thing, check the correctness of equation, conversion of one unit to another unit, then we have seen one numerical, this is this is a homework I have given. Okay, what is the answer for this? Let us solve this. Let us solve. I forgot. Sorry. Let us solve this. Okay. So what is this? I have to convert into another unit. Okay. So just you have to apply the formula. N1 U1 is equal to N2 U2. This will be 2.5 kg meter minus 1 second minus 1 into is equal to some N2 okay centimeter inverse second inverse. Just cross this, this will be cancel out, you will divide this thing, you will get N2 is equal to how many gram? 2.5 into 1000 gram, and how many meters? There will be, remember that is minus 1, okay, because it is minus 1, okay, so that you have to remember. This thing will be cancel out, what you will get? Finally get how much? 2.5 into 100 into power minus 1, so this 2 will be cancelled out by this 2 and this will be 25, okay, this will be 25. Clear? This is my answer. Okay, clear? Okay, then we have seen this thing and the next thing. Now the next thing is limitations. What are the limitations? Limitations of dimensional analysis. There may be some limitations are there, and what are those limitations? Let us see this. Okay, see first limitations. It is not able to find out the value of proportional constant. Okay, you cannot find the dimension of the proportional constant. That is the first limitation. So not able to find value of proportional constant. As we have seen, see, there is a proportional constant is there, we don't know what is the value of that proportional constant. Okay, cannot find the value of exponentials or any trigonometric functions. Or any trigonometric functions. If you have any trigonometric function in the expression, you can find those values. Okay, we have done one example here. Yeah, you can see if it is not there also we cannot determine it, because again the formula what we derive is correct. That's what I told in the last class also. So we cannot derive these values, okay, because they are dimensionless. So that's why we cannot use it. So that is one of the limitation. Okay. Next is, can anyone tell me what is another limitation we have covered? We cannot apply this to the mathematical, like what I am trying to say. Like you can see, suppose this is my equation, s is equal to ut plus half at square. Okay, this is the equation. If you derive this equation, see, by dimension analysis, you will get the expression something like this. Okay, u to the power 1, a to the power 1, t to the power 1 about this plus sign. Okay, you won't get. So the thing is there. You can't derive that expression. Suppose there is a sum of expressions are there, then or difference of expressions are there. There you can't apply the dimension analysis and get the correct formula. Okay, so like dimension analysis cannot tell about the signs that is plus or minus between the expressions. Between the expressions. For example, like ut plus half at, it cannot tell about this sign. Clear? Just note it down. Sorry. sorry 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 Completed? Okay. Now next thing, see, we have covered about the dimension completely. Now the next thing we are going to start is the significant figure. Okay. Now we are going to start about the significant figure. We will solve more example in the practice session. Okay. Our next topic is significant figure. Significant figure. Okay, so what is significant figure? See, significant figure defined as the minimum value you can measure. Basically, you can see. Okay, this is the minimum value. Like suppose, let's take one example better. Suppose I can write 2.001235. So after decimal, how many values I know? Okay, after decimal, how many values I know? That is my significant figure. Means after decimal, how many values I can tell perfectly? That is only going to represent my significant figure. Simply. Okay. So significant figure. So we can define significant figure like this. Significant figure is defined as it tells us about how much after decimal point we are confident. Sorry. Confident about the value. That is only going to represent a significant figure. For example, 2.13. So here how many significant figures are there? There is 3 significant figures. Okay. How to calculate a significant figure? There is a lot of rules are there that we will study. But you should understand that what do you mean by significant figure? It tells us about that up to how much value we are confident. The next value I cannot predict. So that is not my significant figure. Okay. If more, so from here what we can conclude, the conclusion will be there. What is the conclusion we got? So from here we get a conclusion. What is the conclusion? The conclusion is more number of significant figure, more number of figure, more accurate result, more accurate. More number of significant figure, that means more accurate. That is a conclusion we can draw from here. Okay. So that is our conclusion from we can draw from here. More number of significant figure means our result is more accurate. Clear? Now we will see what are the different rules to calculate the significant figure. Okay. So let's see the different rules to calculate the significant figure. Rules. Let's change the color. Rules to calculate the significant figures. Okay. Now what is the rule? The rule number 1. Let's see what is the rule. Rule number 1. All non-zero integer are the significant figure. significant figures. All non-zero numbers are the significant figure. For example, let's take 3.1356, 2.1, 3.3. So how many significant figure are there? 1, 2, 3, 4, 5. So there are total 5 significant figure. Similarly, for example, take 4.136. So how many significant figure are there? 4 significant figure. Simple. All non-zero terms are significant figure. That is the first rule of a significant figure. Okay. Next rule. What is the next rule? That is the zero between the two significant figures, or you can say better, the zero between two non-zero terms. Non-zero is always a significant figure. Is always a significant figure. Is always a significant figure. For example, 1.2035. Okay. So here how many significant figures are there? 1, 2, 3, 4, 5. So there are 5 significant figures. Okay. Similarly, 1.0001. How many significant figures? It is 4 significant figures. So you have to count the zero between the two non-zero element. That is a significant figure. Okay. Now the next rule is initial zeros are never significant figures. Initial zeros are never a significant figure. For example, like 0.001. How many significant figures are there? See, it is an initial zero. This is a initial zero, if you see. So this initial zero will be not treated as a significant figure. This is a initial zero. So this is also not treated as a significant figure. So only one significant figure will be there. Only one significant figure will be there. For example, 0.312. How many significant figure? 3 significant figure. We will not treat this zero as a significant figure. For example, 0003. How many significant figure? 1 significant figure. Clear? So initial zeros are never be a significant figure. Clear? Now the next rule is trailing zeros are significant figures if they appear after decimal. After decimal. For example, like 2.00. See, this 2 is a significant figure. This 2 is a significant figure, and these two zeros are occurring but after the decimal. So this will be also a significant figure. So total we have 3 significant figures. Okay. Suppose we take 2.1200. Okay. So here this 0 will be also significant because it is occurring after the decimal. So we have total number of 5 significant figure will be there. Total 5 significant figure will be clear. Next rule. Next rule is order of magnitude is never a significant figure. For example, that is 2 tell 2 sorry, you will tell only one significant figure, okay, because this 10 to the power 3 is not going to be a significant figure, okay, this 10 to the power 3 is not going to be a significant figure, so only one significant figure we have. Suppose we have 2.013 into 10 to the power some 5, so how many significant figure will be there? 1, 2, 3, 4, so we have only 4 significant figure, okay, that is the way you find the significant figure. And last, most but not the least, that is the results, or you can say better to those values which are not measured they have infinite significant figure. Infinite figures. For example, suppose you know what is the volume of cube. What is the volume of cube? That is a cube. Not this example. Let's take some other example. This is not relevant to it. Okay. For example, like you can take area of or parameter of a square. You can take parameter of a square. Parameter of a square. What is parameter of a square? That is 4a, na? So here this 4 has a infinite significant figure because it is a fixed value. It is in the formula. It is not measured by some instrument. This is in the formula, so that will be the infinite significant figure. For example, like speed of light c, 3 into 10 to the power 8 meter per second, that is fixed, so it has an infinite significant figure. Okay, the significant number of significant figure will be infinite. Okay, for example, refractive index of water, if you remember, it is how much? It is 1.33. So it is also having an infinite figure because these are given by the scientists and they are fixed. That is the value. So it will be considered as infinite significant figure. Okay, so till now we bind up here, and in the next session we are going to do some more example on this significant figure, and then we will cover rounding of the number. After that we will start error analysis, in which we will do study about the different types of error, relative error, percentage error. We will do some numericals, and then we will finally move to the screw gauge and the vernier caliper. Thank you and have a nice day.